Welcome back, everyone. In today's video, we're diving into the exciting world of ESP32 and exploring how to use the analog to digital converter, ADC, and pulse width modulation, PWM, to control a stepper motor and a LED. Please follow schematics properly. We will use ESP32 module, 2-axis joystick with control switch, stepper motor 0 to 180 degree rotation, white LED, breadboard and some wires. Let's get started. First, import ESP32 servo header. Define PWM frequency and set to 5 kHz. Define PWM resolution and set it to 8-bit. Define servo pin 5. This will be used to drive stepper motor. We will declare variable to store GPIO pins 12 and 14 to read ADC input from 2-axis joystick, and declare variable to store GPIO pin 13. We connect this pin to 2-axis joystick push-to-on switch. Declare variable to store GPIO pin 25. We connect this pin to white LED. Declare variable LED state and set it true. Declare variable myServo. Define an interrupt function, and in this function we will flip value of LED state variable every time interrupt is triggered. Inside setup function, we will set up to print serial data to serial port and set its speed. The LED-C attach function sets up an LED-C pin with a given frequency and resolution. LED-C attach channel function is used to set up LED-C pin with given frequency, resolution and channel, which in this is channel 0. We call attach function and set it to servo pin. When calling servo attach function, the servo motor rotates to the last value set by servo right. Here we make switch pin as input pull-up. Whenever you configure any digital pin of Arduino to input_pull-up, an internal resistor inside the Arduino board will be connected between the digital pin and the power VCC. Use attach interrupt function to call a function when an external interrupt occurs, in this case when SW pin is pressed, which is connected to ground. Interrupt is triggered when SW pin voltage is rising. Inside loop function, we read analog voltage from pin 12 and 14 and set it to variables. These analog voltage is changed from 0 to 3.3 volts from 2-axis joystick potentiometer and is transformed to 12-bit value range from 0 to 4096. Here we use map function. It takes an input number within a specific range and maps it to an output number within a different range. Here we used 0 to 180 degree stepper motor. We can change these range for fine control. Print the x-axis analog value and transformed value. Now we pass servo value variable to right function, which cause stepper motor to rotate on value change. Now we map analog value received from y-axis and transform it to 8-bit value, that is 0 to 255 value. Now we will use logic to turn on LED light when LED state value is high. This LED state value is flipped every time when joystick button is pressed and released. Also, when LED state value is high, we will use pulse width modulation to change brightness of LED light. Now print the y-axis and brightness value. And add 15 millisecond delay. And we will upload the code to our ESP32 dev board. Now I am shifting the joystick at y-axis up and down, which cause white LED to change its brightness. Here we have used pulse width modulation generated from GPIO pin 25. Also, shifting the joystick at x-axis sideways cause stepper motor arm to rotate from 0 and 180 degree. Note, at rest position, arm returned to 90 degree. This is very useful as controlling RC airplane rudder, aileron, landing gear, elevator. RC helicopter pitch, rudder, collective. RC car front well direction and such. If you find this video helpful, don't forget to smash the like button, subscribe to our channel, and hit the bell icon so you never miss an update.